I'm not sure what your expectations are. It says BIM up there. Not a great deal about BIM, but there's some. I'm leaving the technicality bit of this to my colleagues, not my colleagues, my friends in MOTS who follow on from me. They're far better qualified than I am to talk about the technical aspects. I'm only a humble project manager and not an engineer. So we'll look at some London Underground station projects and how we've used technology to deliver them. And I also want to talk about how we have used collaboration to achieve the successes that we have. But first, I'd like to do some background and sort of set the scene for why we have a station building programme and why we spend so much money on it. There are 1.3 billion passengers a year that use London Underground. You only have to consider, with that footfall, the wear and tear on the existing assets. And so there is a full-blown capital programme employed in keeping those assets up to scratch. But that's not the story, is it? It's not the whole story, because as we all know, London is growing. The population of London has increased by 1.5 million this century. And what does that mean? Nothing comes without 6 noughts on it these days, does it? So what does 1.5 million people mean? I used this slide in a presentation in Newcastle last year, and to contextualise it for them, I pointed out that that meant that the whole population of Tyneside had moved down to London over that period. Or I said that if they preferred a northwest analogy, the population of Carlisle moved to London last year. And I think that puts in context really how fast London is growing and what's going to happen over the next decade. That slide shows that over the next decade or up until 2030, there are going to be billions more trips made on our roads and metro infrastructure. Because what is happening is that not only is the population rising, but they're travelling more. And those 1.5 million people that have come to London in the last decade have used the tube more than they were doing previously. So the use per person is going up, as well as the footfall itself. So over the next 20 years, up until 2030, say, it's predicted that growth will continue at 1% a year. That's 1.25 million extra journeys every year. That means roughly 50,000 additional journeys per business day. And that's Birmingham. So to continue with our city analogies, the population of Birmingham is going to move to London by 2030. So we cope with that. Well, this is just some other analogies of what it all means. 6 new residents every hour, all that stuff. And it means increased platform congestion. We increase the capacity of our network by smart signalling systems, so we can get more trains down the track. The Piccadilly line is up for an upgrade, which means that it will increase capacity by 40%. On top of that, the new Piccadilly line trains, which will be the walk-through trains like we have on the Circle line now, will increase capacity by another 20%. So that's a 60% increase in capacity on the Piccadilly line. And if you don't increase the capacity of the stations to handle that, it means your train's non-stop, and actually you're taking a lot of passengers to places where they don't want to go. So by 2026, 30 stations in central London will be experiencing traffic loading of over 4 people per square metre. Now, I have a shower cubicle at home and it has a footprint of 1 square metre. I prefer to choose the other 3 people that come to the shower with me. But you don't get that option on London Underground, unfortunately. So what are we going to do about that? So let's think about what we have been doing. And I'll go through a few projects that are now reaching completion that have been specifically focused on increasing capacity within stations. So that's the oldest, I get them mixed up, the Astoria or the Adelphi. I think that's the old Astoria Theatre at Tottenham Court Road that we knocked down to build our new station. And the current station, actually, the project is almost finished, but the old station at Tottenham Court Road experienced 150,000 passengers a year, and with the arrival of Crossrail, that's going to go up to 200,000. Sorry, every day we'll go up to 200,000. So we've increased the a far larger ticket hall. We've got more entrances. We've installed 5 new lifts, and we're providing new escalators for the Northern Line and the Crossrail services. We, London Underground, also built the box that Crossrail will fit out for their eastern entrance to Tottenham Court Road station. We will complete that early this year. That's the old ticket hall at Tottenham Court Road, very congested, looking rather old-fashioned now, although I'm sure it looks state-of-the-art in its day. And that is what it will look like when it's finished. Actually, it looks like that now. If you went there now, you would recognise that. And that's an area of what it will look like. About the only thing that's not finished is the external works and that urban space there that's not quite complete. So big project, 500 million quid, very nearly complete. Bond Street's a similar story. The arrival of Crossrail, with which it interchanges, will increase its footfall per day from 150,000 to 225,000. So clearly it could not cope. And I'll pause on Bond Street a bit just to give an idea of the effort that goes into building these new underground spaces. I mean, Bond Street really is keyhole surgery. There is a very small footprint on the side of Oxford Street where all the work was done from, and through these 2 shafts all the work was complete. And that work included building 550 metres of new passenger tunnels, which meant excavating 17,626, it's very precise, isn't it, cubic metres of spoil, and 46,000 tonnes of, that equates to 46,000 tonnes of stuff. And that all went out a small road at the back there. And it really is quite extraordinary how the public walking past that blue hoarding would never know the amount of effort that was going on underground. We also had to underpin 2 Georgian Grade 2 listed buildings, and it is the only London Underground tunnelling that goes through 2 African countries. To explain that, the Tanzanian and get this right, Botswanan embassies, our tunnels bypass them. They have to bypass them because they are sovereign land of those embassies, and their right to sovereignty goes to the centre of the earth. So we were not able to tunnel underneath those embassies. We had to go round them. Going under them, obviously, wasn't an option. So that's all been done with minimal impact. And I'll come on a bit later to talk about ground movement and how we've managed to prevent those buildings being adversely affected. That's Bond Street. So Victoria, similar story, and I know that my friends in Mott's are going to talk about this as well, where they had a big involvement. The same sort of thing, greatly increased underground spaces to allow more passengers to move. If anybody uses Victoria Station, they will know that it's grossly congested, that the gate line is frequently closed because of congestion downstairs, and it was crucial that we increase the flow of passengers so that the station could continue to be efficient. And this is virtually complete now. I'll come to this later as well, and I know that Mott's going to talk about it. We had the ground that we had to tunnel through was of a very poor quality. It was made up ground, had been dug over for years. So we had to improve the ground by injecting large amounts of grout, but I'll come to that later. And these are just pictures of the station during construction. And the last picture is how it looks today. I don't think that's an architect's rendition because it's raining. And you can use that entrance now. There are some more refinements to continue underground, but the station is essentially complete. So, that's facts about it, 700 million quid, etc. How have we in London Underground used technology? Well, we like BIM and we aspire to BIM, but we're not quite there yet. Our whole life asset management aspirations are complicated by legacy issues. Through the PPP that you might all remember, we now have 4 separate asset management systems, and that frustrates the assimilation of data from new projects as they create it. Crossrail is wholly embracing BIM, and they will pass over to us a complete BIM package, and each asset will have a tag like this. And this asset is called Charles Mills, and it is CRL CM001. And if you scan the thing here, it will tell you how often I need servicing, what my maintenance regime is, and when I need to be replaced. So that's a big step forward. We would very much like to extend that over all our assets, but you know, we're 150 years old, and the problem of doing that is great. However, we do aspire to have all our asset management systems combined by 2018. So that's a step in the right direction. In construction, however, we are enthusiastic users of common data and 3D modelling. It'd be difficult to do some of our excavations in complex underground conditions if we didn't use that. And this picture here shows the Crossrail westbound tunnel going within 1 metre of the Northern Line at Tottenham Court Road and through those other structures that have been built there. It'd be difficult to do that without using technology and BIM methods. Other examples, that is a map of the underground services under Oxford Street outside Bond Street Station. And we have to dig and excavate through that. It would be almost impossible to do it if we didn't use this technology, or it would certainly take a lot longer time and be a lot more expensive. The amount of intrusive surveys you'd have to do, you'd have to dig up Oxford Street to find out what was there and then put it back down again, which is hardly feasible. So BIM at Victoria, probably the station where we embraced BIM the most. We've used it extensively in declashing our services and in coordinating our contractors' activities in the fit-out stage. But perhaps most importantly, I spoke earlier about the ground conditions, and this was the first large-scale use of jet grouting techniques in the UK. The ground was very poor. Tunnelling through it would have been difficult and dangerous. So essentially, we've filled the ground up with grout. And there are 2,200 1-metre diameter jet grout columns put in there, designed precisely for where the tunnelling needs to go through. Also, through BIM techniques, we were able to identify where there were unavoidable voids in the structure, so that as we were tunnelling, we could mitigate that by draining off pockets of water that we knew through our modelling existed. And obviously, we used the modelling to avoid all the various and numerous underground services that already run through there. Not everything went perfectly. It is, I don't know if any of you heard, but just over here is the Astoria Theatre, or is it the Adelphi? We filled up the control room with grout just before a performance, which obviously meant that that performance didn't go ahead that night. Because you're never quite sure where this stuff's going, you know. You squirt it into the ground, it can come out anywhere, however good your modelling is. So, other uses of technology, I think it's worth pausing on and considering is you can't dig all these holes in the ground without there being some effect on the ground above it. And we do a great deal of ground movement monitoring and monitoring the movement of buildings. Just to give an example, on the Crossrail tunnel, just for the tunnel, not for the individual stations, there were 30,000 sensors like this. That's on a rail, but they're on a building. 30,000 sensors that were monitored on an hourly basis. Similarly, when we were building Tottenham Court Road, we had sensors all over the place, and there's a house very close to it called the House of St Barnabas, which is a Grade 1 18th century listed building, and incidentally was used by Bazalgette as an office when he was building his sewers, and it's famous for its Rococo plasterwork. God, you don't want that cracking, do you? And actually, in the room with the best of the plasterwork, there's a crack in the wall that was existing, and we monitored that, and we could tell the owners that that crack opened by 1.5 millimetres during construction and then closed back up again. So that's the type of precision you can get from these monitoring processes. We mitigate the effect of grout movement by compensation grouting. This is a picture of the TAM arrays from a shaft at Bond Street. TAM, I know you're going to ask me, means tube à manchette, which I believe is French. And what you do is you drill all these holes and you squirt grout into them at precise places to compensate for where you think the ground movement is going to be. It's very iterative. It is planned on a daily basis. You take the data from your ground movement readings, and then you plan where you're going to put your grout injection that day in anticipation of where the ground's going to move. It's been highly successful. The longest of those pipes, by the way, are 85 metres long. It shows you how wide the zone of influence is from that sort of excavation. And we never damaged any building, and we were able to mitigate predicted ground movements of up to 30 millimetres down to 5 or even 10 millimetres. And in all, we injected 500 million litres of grout in that area. And you think of that going on all along Oxford Street, from the stations we're building, the stations that Crossrail are building. That whole area is going to be very solid in the years to come. So, our next phase, those are the stations that we have just about finished building to mitigate the overcrowding risks. The next phase of stations are now in design. That is Camden. Believe it or not, Camden Market is one of the top 5 popular tourist destinations in London. And if you go there at a weekend, Camden Station is exit only. You can't get back into it. So we are building a new entrance and a new range of circulation spaces underground to allow constant use of it. This is Holborn. People are frequently held outside Holborn at peak hours because you can't get in because it's too crowded downstairs. It is a major interchange, but you can't use it as interchange at peak times because it's too crowded, so interchange isn't allowed. Therefore, new entrances, new tunnels underground, another major station project now in the early design phase. One that is just kicking off, that's more of Holborn. Bank Station. Bank Station is a massive project we're just starting. It means building a new tunnel for the Northern Line, and so that it can be diverted so there's more space for extra platforms, and a new entrance some distance away and a travelator to bring the passengers from where they are and take them out again. I'm going to talk a bit more about Bank Station actually, because it is, there's another visualisation, large job. bit about collaboration and a bit about innovation as well. We're often criticised, aren't we, in the construction industry that we don't innovate. And one of the reasons we don't innovate is that you don't get paid for innovation. So there is no incentive on behalf of the contractor to innovate. So in order to address that on bank statement, we used a new procurement method called innovative contractor engagement. And basically what we did is we gave our REBA D design to a selection of bidders and said you can either use that design, which we think is very good, or you can come up with a design of your own. And we will supplement your bid costs and we will buy from you any innovations that we like, even if you don't win the bid. And the way we assessed the bids was on value rather than cost. I mean, cost was obviously assessed and had a certain weighting. But one of the major weightings that added to value was the speed of transit through the station. So that's why the Travelator won, because they got the people through the station quicker. And the cost benefit was positive, and therefore they won that bid. And it also means that that is their design, it's not our design, but we're buying it from them, so it becomes our design, the bigger our. So there is a far greater incentive to collaborate because we own design jointly. It got lots of press coverage, and that is the headlines of what the process saved. 23% cost reduction, 19% improvement in journey time, and 50% additional value over our base case, which we thought was pretty good. So to speak, the answer is out there. We need to engage and collaborate with the supply chain to ensure that we get the best solutions, because they have more knowledge than we give them credit for. Back to Bond Street and more examples of collaboration. We were having problems with the contractor at Bond Street. We had commercial problems brewing. So what we did is we developed a completely integrated team. We didn't have a client team and a contractor team. We had one team. And we filled the posts through the most qualified person. So some of those posts are filled by London Underground, some of those posts are filled by the contractor. And the effect of that was felt. The wording on this slide is slightly wrong. It's not NCE. So it's a new engineering contract. And those of you who know about these things will know that you have to agree a program on a regular basis with your client. And you can see that prior to the one team formation, we weren't getting programs agreed. But afterwards, you can see that agreement became more frequent. And here we are, it's a smart screen down there at the end. We are getting rapid and complete agreement on programs. So that's an example of how that one team and increased collaboration worked. This is about Crossrail, and this is about how collaboration reduces risk. Back in the day when Crossrail was first being considered, or not first being considered, when it was coming close to being instigated, the Crossrail risk register held £1.2 billion of risk in anticipation of London Underground screwing them up. There was an expectation that Crossrail would lie down in front of the TBMs and generally stop the project going ahead. Likewise, on our side, I think we thought that Crossrail was probably a very bad thing because they'd mess up all our assets and make our trains fall over. So clearly we had to get together, and over the years we got close together, and sometime around here we put together a London Underground Crossrail team. We developed a collaborative agreement, and we started to work together closer and closer and closer. And over that period of time, the risk on the Crossrail risk register allocated to problems with London Underground decreased by £1 billion. So that's tangible example of what collaboration can do. It reduces your risk. And that risk money that had to be allocated there can now be spent on something else, and has been. And this is how we do it. This is a dashboard that my colleague David helped us put together. We engaged with David and his expertise in collaboration, and we had a very fruitful partnership. And this is, I think collaboration doesn't work unless you measure it. It's no good saying we're collaborating, you want to know how you're collaborating. So with Crossrail, at the start of each year, we would set out what commitments we had to each other. So here we have Crossrail's utilisation of possessions. We shut down the railway so Crossrail can do work. We want to ensure they're utilising that to its best effect. We have here things about document control and the assurance process. And we have here a regular survey we did of all the people on the interfacing teams about what their opinions were of the other team. And from this, we would analyse the answers and develop an action plan for where the effects of collaboration appear to be falling off. And we would set, each of these goes into a system that calculates what your score is, and we would set an overall score improvement over the year that we were incentivised to hit. So that worked very well, as you can see, and we brought the risks down by £1 billion. I borrowed this slide from David. I hope he didn't use it earlier. You aren't seeing it twice. It's about the iceberg. And we kid ourselves if we think that technology can lead the way unhelped to collaboration. And we kid ourselves if we think that processes are going to get us to collaboration. It's about human interaction. And what we have just above the surface are all those hard things, like the formal relationship, like the management structure, like the rules, like the systems. But below it, we have the human aspect. We have human needs, we have suspicions, we have expectations, we have culture. And unless we address those, we will never collaborate fully. And I think that is all I had to say.
Thank you very much.